Alright, so here's our examples for this topic. The instructions say factor each trinomial. The first trinomial we're given is 3x squared plus 10x plus 7. Okay, so the strategy to factor trinomials is to reverse FOIL. Right? And the steps to reverse FOIL are first to write all the factors of the a coefficient. So this is a, this is b, and this is c. The factors of the a coefficient are only 3 and 1. It's the only way you can break down 3. For the c coefficient, since it's a prime number, the only factors here are 7 and 1. So now we're going to go to our boxes and check which combination of these factors will FOIL back out to give us the 10 in the middle. So, because our a coefficient was prime and our c coefficient was prime, there are not a whole bunch of choices when we start filling out our box. In the first column, we have to put factors of a. So let's try 3 and 1. In the second column, we have to put factors of c. Now, what we could try is 1 and 7. I'm telling you right now that this is going to be a silly choice, right? And maybe you're seeing why, right? When we go to check the diagonals here, we have to do 3 times 7, which is 21, and then 1 times 1, which is 1. There's no way 21 and 1 are going to combine to give us this b coefficient of 10. All right, so that was a silly choice. So what else can we do? Well, you can always flip the numbers in the second column. So let's try again. So I'm going to put 3 and 1 in the first column once again. But now I'm going to make a smarter choice in the second column. Instead of putting 1 and 7, I'm going to flip and put 7 and 1. Now when we check the diagonals, 3 times 1 gives us 3, and 1 times 7 gives us 7. Those are going to add up to 10, which is exactly what we need for our middle coefficient. Right? So this is the box that's going to lead to our factored form of this trinomial. So to factor this trinomial, you break it into 2 binomials. The first binomial comes from the top row, right? It's going to be 3x plus 7. So this guy's got to have an x and this guy's got to have an x in order for us to get this x squared back. So in the first binomial, we get 3x plus 7. And then in the second binomial, we get the bottom row, which is 1x plus 1. There's really no need to put the 1 in front of the x. So ultimately, this factors into 3x plus 7 times x plus 1. So here's the next trinomial we have to factor. Right? It's 5z squared plus 12z plus 4. Right? So the first step is to find factors of the a coefficient. So let me label my coefficients. Here's a, here's b, and here's c. So I'm going to find factors of my a coefficient. Again, this is a prime number, so my only factors are 5 and 1. For my c coefficient, though, I have more choices. 4 is not prime. So when I get to my second step and factor this 4, I have to consider 4 and 1, but also 2 and 2. Now let me go ahead and check to see which pair of factors is going to work, which 2 pairs of factors are going to work, all right, by using my boxes. Remember, in the first column of the box, you put pairs that multiply out to 5, that multiply out to a. So I'm going to put 5 and 1 here. In the second column of the box, I put numbers that multiply out to 4. Now, in general, I like to start with the numbers, the factors that are closest to each other. So I'm going to start with 2 and 2. does this combination check? Well, we have to multiply the diagonals to find out. 5 times 2 is 10, and 1 times 2 is 2. 2 plus 10 is 12. So we did get back this middle number, which means this box tells us how to factor 5z squared plus 12z plus 4. The first column, remember, is going to have the variable attached to it, so we're going to have to put a z and a z to make sure we get back this z squared. Now we can just read off our two binomials by looking at the top row and the bottom row. Our first factor here is going to be 5z plus 2. And then our next factor is going to be 1z plus 2. There's our factored form of this trinomial. If you wanted to be doubly sure that this was the correct factored form, on top of filling out the box, you could also refoil this and check to make sure that it is the correct factored form. Let's do that quickly just so you see how you can check. If we didn't believe in the box, and if you didn't believe anything that I've been telling you, or if you were just not sure and you wanted to be sure that this was the factored form, you could take 5z plus 2 and multiply it by z plus 2 by foiling. You would do 5z times z, which is 5z squared. Then you would do 5z times 2, which is 10z. Then you would do 2 times z, which is 2z. And then you would do 2 times 2, which is 4. Finally, after collecting like terms, you'll get your 12z back in the middle. So altogether here we'll have 5z squared plus 12z plus 4. So this does check out, right? The binomial 5z plus 2 multiplied by the binomial z plus 2 does give the original trinomial 5z squared plus 12z plus 4. Right? And if you look, you can now see how the box works. Right? The 10 encodes this 10z right here. The 2 off the diagonal encodes this 2z right here. Right? The 5 and the 1 multiplied give you this 5. And the 2 and the 2 multiplied gives you this 4. Right. So this is the correct factored form. So we're good. All right, so here's the next trinomial we have to factor. It's 24y squared plus 62y plus 33. So the first step is to break down the a coefficient. Let me label my coefficients. A, B, C. Unfortunately, the a coefficient is kind of beastly. All right, so when I break this down, I have a lot of options. It could be 1 times 24, or maybe 2 times 12, or perhaps 3 times 8, or even 4 times 6. All right, that's it. 5 doesn't work, and when you get to 6, you'll start repeating. Right? If you did 6 times 4, you already have that listed, so you don't need to list it again. The c coefficient isn't quite as bad when we go to our second step and break that down. The c coefficient is 1 times 33, but then 2 doesn't work because 33 is not even. 3 works, 3 times 11, and that's it. 4 doesn't go into 33, 5 doesn't go into 33, etc. So now we turn to our boxes to try and figure out which 2 pairs of factors will multiply out to give us this 62 in the middle. Now, there's a bunch of combinations we can try here, and I highly suggest using some sort of pattern, okay? And moreover, I like to start with the factors that are closest together. So as I go through and make my guesses, I'm going to start with 4 and 6 for my a factors. And then I'm going to use 3 and 11 for my C factors, since those are closest together. Now what happens here is we actually get really lucky. 4 times 11 is 44, and 6 times 3 is 18. 18 plus 44 is 62. So it does actually check out and give us back the 62 in the middle. It's just luck in this case. Okay, if you would have started with 1 and 24, then you would have had to go through 1 and 24, 2 and 12, 3 and 8 until you finally arrived at the correct box. Okay, and it doesn't always work that the closest factors are the best or the correct factors. Just in this case, they were. Okay, so that being said, we can put our variables in here. There's a y squared, so we put a y in front of each of our a factors, and then we can finish off the factoring by making two binomials. The first binomial comes from the top row, 4y plus 3, and the second binomial comes from the bottom row, 6y plus 11. So there's our factored form. Pretty slick, huh? So here's our last example for this topic. We have to factor 6 plus 7x plus x squared. So it's a good idea to make sure that your trinomial is written in descending order before you start using this factoring procedure. Technically speaking, you could do it. You could factor this trinomial without writing it in descending order, but there's no reason to. You might as well write it just like all the other trinomials that we've been factoring. Okay, put the term with the highest exponent first, followed by the term with the next highest exponent, and lastly the constant term. Okay. Now label your coefficients. This is kind of tricky because the a coefficient is the number in front of the x squared, the number in front of the squared variable. In this case, because there's no written number in front of the x squared, we know we should think of this as 1x squared. So our a coefficient is 1. The b is 7, and the c is 6. So when we start factoring down our a and our c coefficients, for a, it's real easy. There's only one possibility. 1 is 1 times 1. For c, there's a couple possibilities. 6 is either 1 times 6 or 2 times 3. And now we have to turn to our boxes to check and figure out which two pairs of factors work. So in the first column of the box, we always put factors of a. So 1 and 1. That's my only choice. In the second column, you put factors of c. If I'm following my usual procedure, I would start with the factors that are closest together, 2 and 3. Does this work? Well, we got to check. 1 times 3 gives us 3, and 1 times 2 gives us 2. 2 and 3 add to 5, not 7. So this box is no good. Try again. Now, you always want to try the same factors but flipped for the c part. So I'm going to keep this 1 and 1. I mean, you can't really flip those anyway. And I'm going to flip this to 3 and 2. But you'll notice because these factors are the same, this doesn't change much. 1 times 2 is 2. 1 times 3 is 3. 2 plus 3 is once again not 7, it's 5. So this box doesn't work either. All right, let's try another one. So we've exhausted all the combinations that have 2 and 3. So we know that pair of factors is not going to be in our final factored form. So let's move on to 1 and 6. I'm going to put 1 and 1 here, and I'm going to put 1 and 6. And if we check, 1 times 6 is 6. 1 times 1 is 1. 6 plus 1 does add up to 7. So this box checks. Right? Since we're trying to get an x squared, I know this is going to have an x and this is going to have an x. So our final factored form will come from the top row and the bottom row. So the top row tells me I must have x plus 1 as my first binomial, and the bottom row tells me I must have x plus 6 as my second binomial. There it is. There's my factored form.